Hello everyone, this is Riley. Some background story. If you have watched my instancing or not live noding, you may realize in the past I had a template to generate the spline from math. However, in my recent project, I need to work with this template a lot. And to duplicate a template means generating lots and lots of spaghettis. So I end up making it into a subprogram preset. And this story told me that despite some advantages that I can think about having template system in animation node, the actual experience working with the template is miserable in my opinion. It's still good if the developer make it, but at some level I'm against that reason at this moment. Unless we found some easy way to actually shorten the usage of nodes or reduce the spaghettis and some other things. But anyway, so today we're going to make the knot generator preset. So here is a very basic setup of the knot generator. So now nothing looks very special. Let's firstly take a look at the output of the actual knot generator. It outputs a lot of vectors, and let's set that to red. And if we increase the number, you can see it generates a lot of points. And by connecting all these points, we get a splines. And we can smooth that out to use the smooth better splines, and finally output that a curve object. So we get a curve object with such kind of shape. And at the current moment, it does not look like anything special. But as soon as if you increase the other parameter, then it generates whatever weird shapes. And you can also enlarge or decrease, reduce its size. Basically, all these things are parameters that you can play with. You can use the bevel depth to change the thickness. And yeah, there are lots of patterns that you can potentially generate it. So if you look from the top view, then you get the essentially kind of animation that I've got last time, as you have seen. But just to be aware, this is definitely a 3D setup. So you can change all these values as you wish, and it generates, I don't even know what you call it, but it's something abstract, something crazy, whatever. Interesting, fun. And it's a 3D setup. So essentially, because this is a curve object, which also means you can actually make it follow splines, follow the path, or even instancing object on this knot. So this is just one of many ways to play with that, I suppose. So anyway, so basically this is the idea. So next thing is we're going to build this knot, or how to use math function within this animation node. Since we're going to talk about a math function in animation node, let's firstly get some math formula. And these math formulas are basically all about knots I've made in the past. All these formula are actually from a website, and I will post all the reference link from the description. My profession has nothing to do with math, and the only thing I can actually read from the entire formula is actually the sine and the cosine. But I think as long as you have learned trigonometry, this is not hard at all. And that's basically it. And here, what you can actually realize is basically all the knot function follows the same principle. So for x, it's always cosine and cosine. For y, it's always sine, sine. And for z, it's just a simple sine wave. It's only the parameter, which is the blue part, that tends to be different throughout. So here we have a base formula, which has been stated at the beginning of the reference. And we're going to use this base formula to do our preset. So let's start to do our lovely preset about how to actually use the math formula to generate splines. Since we're talking about the math formulas, one thing potentially you can think is to use the float math. And just in reference to the torus knot, suddenly you can change these the math into cosine. And we're going to make a multiplication times 2 and connect it to cosine, and we are going to add a numbers and to another product from the cosines, and in cosine it contains another multiplications, and the cosine by itself needs a multiplications. And instantaneously you can see we are already generating 6 nodes just for a single x, and it makes your life miserable. Actually, it makes my life miserable. So this method is actually not recommended. It certainly will do your jobs, especially if you combine everything into the formula base. Probably you won't really care what has been actually contained within the formula. However, this makes my life miserable just to build a single x. And just thinking that if you're going to change the formulas, for example, I'm going to use a hard formulas, then there's nothing similar to the formula or it's not. And especially if you look at y's, it actually contains 4 cosines. I don't know how it actually works, but it's just how it works. So it makes your life miserable. My answer is no. So we're going to use another method, which is called the expression method. And in expression method, you just basically type formula. So give you kind of very simple examples. I'm getting 2 times 3, and I get 6. So we're going to hit W, and it goes to viewer. So we get 6. And if 6 divided by 3, then we get 2. There's also, for plus and minus, it's just nothing that I need to specifically state, just a plus minus. Other symbols, for example, square root is just a square root. So square root of 16 equals to 4. Another important thing is because if you're working with hard formula, then there is an exponent. And the exponent is basically 2 times 4. Then you get 16 back again. It's basically idea. So if you are not sure what's actually exponent or power, then it's just 2 times 4 equals to 2 times 2 times 2 times 2. So basically you have 4 2's times together. Something like that. And you just get a kind of idea. So, and that's basically it. So here I'm going to basically just copy a x to the expression, and it will tell the x is not defined. I'm going to take a float input, put the float into new input, and you can see I'm inputting zeros, and after running through these formulas, I get an output of 2.5. And you can actually add whatever numbers, you get whatever numbers, and you can see it's actually cycling through. It never goes beyond like 3 or 5 or something like that. It's just a looping, as what we see from the NOT, because this is what the NOT is actually doing. And because we're going to generate multiple vectors and multiple numbers, multiple x, here I'm going to take a float range. For example, I'm going to input in 100 numbers. So let's delete these inputs and redefine the x to be a list. And it will actually give you a warning sign that it tells blah 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 stuff. Although I'm not a programmer, but just by reading the English, you can finally realize it actually simply tells that it does not receive a list of numbers. So it's okay to put a single float, but it's not okay if you put multiple floats. So how can we actually input multiple floats to get a list? Here we're going to use a loop. So we're going to hit W and it goes to right. It's basically how it works. And the one thing to be aware, if you're really going to build a preset, you need to save that into the startup file. Everything basically has been explained in my preset basics tutorials. So if you haven't watched that, I recommend you to watch that. It's basically kind of idea. So within the loop, you input a list, and within each. So for the loop, you input a list, and within each loop, you input a single value from the loop. And this is how we connect the float range into this loop. So now we get an output number. The viewer only shows the last loop, the product from the last loop. So you don't need to really worry about that. So now we get the basics done. This is just an X for the triple knot. But we may not only work with triple knot, we may work with other formulas. So let's just copy our base formula and paste that. So you can see there's a lot of other numbers that you need to define. And you cannot directly put the new input back to parameter, because you need to firstly define the new input. So we need to define everything into float. And because everything has been a parameter constant, so I'm just going to put using the parameter instead of iterator. For details, you can watch my other tutorials talking about when and how to use the loop, something like that. So float, and basically I'm going to duplicate this and type in a completely different formula. And then I'm going to duplicate again for z, which is h sine t times x. So I'm going to put x into that. But the rest of the number is not relevant, so I'm just going to change that to h and t. So you can paste another float, h, and another float, which is t. We take h and t and then we can delete the rest to numbers. So now we get 3 dimensions x, y, z. We're going to combine that to vectors. One thing I forgot to do, this is now it's outputting a general list. I don't know if I actually can do the work, but let's combine the vector first. So can we actually connect to that? Yeah, it seems working. It will automatically converts the general list to a float list. So now we did the work. So now we convert everything into a vector. One thing I would like to do is to be able to scale the entire things up and down, like what we have done with this scaling. And this is simple to do. You just take a vector math. I'm not going to change that to scale. So I'm going to change the factor to 1 and connect that back to parameter, so that the default value of this preset has a value of 1. You can also change the every other things to 0 as well. If you would like to change the default number of a preset or subprograms, it just goes to the original trees and change the value from here. So by default value, I'm going to change everything to 1 because I think it's a kind of very nice starting point. And basically this is it. Finally, we're going to hit this plus icon and output a vector list. So now we have a kind of get a very basic idea about how everything actually has been worked out. But this is still not a preset because you can realize I only have one node in this not generator, but I have a float range. So here what I'm going to do is to group this entire thing into another preset, which is called a group input. So we put the number into that, and then we put basically put all the numbers into 1. So I'm going to change the type to stop, and I'm going to connect the rest of the parameters back to the group input. And then I'm going to hit this output node to output this vector list. I'm going to name this as a not generator tutorial. So I'm going to hit W and create an evoke node. So here we have our not generator replicated, and let's just test this function to see if it actually works out or not. So let's hide this target. We're going to connect the vectors and make another target. And you can see, well, there's a thing that we generated. So now this preset still isn't completed because you can see these full circles. Actually, it does not form a full circle at all. The reason is because when you are working with sine and cosine function, to loop that you need 2 pi. This is how it works. So what you need to do is type 2 pi's in the stop to form a full circles, and still up to this moment it hasn't been completed. And you can see there is a glitch in the end. So if you turn off the cycles, the glitch will disappear. And you can see the reason actually to have a glitch is because the starting point and end point is actually overlapping each other. And if you turn on the cyclics, it connects itself, but you loop the starting and the end point together. So to solve this problem, it's actually easy. You just not include the endpoint, and it will solve the problem. Sometimes it's not always that you need to deactivate this endpoint. It depends on the function you're working with. Because here we definitely have two patterns. Because if you increase this p to a different function, you can realize this formula will actually work better if these p and q are integers. P, q, t are integers. That's why I have a not generator one, where all parameter has been integer, which has a bright blue color instead of float input, which has dark purplish colors. But sometimes maybe you would like to animate these things in a very interesting fashion. That's why you need a float input. But if you are doing everything statically, then I recommend you have a integer input. So this is why I have two not generator, because it's very hard to decide what exactly I want in this case. But if you just would like to have an integer input, you just take integer input and put that to p, q, and t. Then it's basically the idea. I think this part is not very hard to understand. Another thing is I don't like to type pi. I mean, type pi is very, very important in this entire thing, but I don't like type pi. So instead, I put everything within these presets. So I take a float math, and I'm taking constants, make a 2 pi's. So outside these presets, I just need to type 1. Then it means I'm running a full cycles. And if you delete ones, then it's not a full cycles. But basically, I just keep that 1. So you can decide whether to change these values or not. But it's kind of ideas. And now you can just play around with these things. And the formulas still makes sense because you can generate some specific patterns. It will actually be very, very interesting. Please take a look with the reference and try to see what kind of shape you can generate from that. It's actually more interesting than you think. And basically, these are things that you can potentially play with. And here's some other things that I would like to mention. Is this node is still kind of under development because this is a very base form of how it works. But you can add some additional feature. For example, one feature I add is actually the transformation. So what I do is basically transform vector. And even if you don't add any matrices, this loop is still working. And you can put this matrix to the place. I'm going to name it the transformation. Let's also change other names like resolution and scale. The reason I added transformation is because so that rotation matrix, I can rotate this thing easily. So maybe sometimes you would like to have whatever other things to be played with, like in front, looks like another pattern, something like that. It's just a thing that you can potentially do. You can also change the scales, like increase X and Y's, so on. You can also change the locations. So these are ways that you can potentially play with that. There's also other cases like if you want to generate a spline within this preset, then you just put these two nodes within the preset. It's okay. The reason I didn't do that is because there are so many settings within this spline from points, and to include all these settings within this preset, it will make this preset a little bit long and large. So I decided not to do that. Also, there are some other reasons that I decided not to do so. Additional things is like, but sometimes maybe you want to put these two nodes within the preset. because maybe you want to instance objects to evaluate the spline back. These sort of thing has been essentially shown in the instancing on knots tutorial, but I also think I'm going to make additional tutorial talking about all these kind of features in the future. So anyway, but this is basically an idea. So just to play with that. If you would like to achieve the animation that I've done in my demonstration, you just play around all these values. Then you get whatever things you want. It can be very crazy to generate possibilities. You can see this is kind of weird shapes. I don't even know what have I actually done? Kind of I don't know, flowery, whatever, kind of anything. And also to remember that essentially you can do more math function within all these 3 dimensions, and certainly you can generate a hot as well, but it does not have a z-axis. At the end, we are still doing work with splines, so it might be better if it's just generating splines and so on. Something like that. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.